Hey everybody, welcome back to Tech Junior Tutorials. My name's Lee Warwick Jr. and we're doing Advent of Code, day 7. So this weekend, Saturday and Sunday was days 7 and 8. Today is Sunday for me. So it was kind of tough to do these puzzles over the weekend. Had very busy weekends with Christmas just around the corner, so lots of going to see lights and spending time with the family. But I managed to get these done in the morning and at night whenever I got home. So let's talk about day 7. So day 7, lo and behold, is using the old Intcode computer again from days 2 and 5. But they've put a little twist on it, of course. And for part 1 of day 7, they've got this chain sequence going on where you have like amplifiers for your thrusters or something for your I don't know, Santa rocket ship. But in any case, essentially the problem is you've got 2 different inputs that are going to go into your Intcode computer. The first one is the signal, which starts at 0, and the second input is the phase. So they tell you down here you're going to have a sequence of phase settings, one for each amplifier, so a 5-digit number. And they tell you that the inputs are going to come in a certain order. And I cannot recall if it's phase first or input first. I think I have a comment for it in my code, so let's check it out. Yeah, so the first, I had to read it very, very carefully. The first input that the Intcode computer picks up is the phase setting, and then the second is whatever the input signal is. So for the first amplifier, it's going to be 0, and then that is going to output some kind of signal that is then going to be put into amplifier B. B is going to do whatever it does and then output something into C, all the way until we get to E, which gives us the final signal. And so part of the puzzle was refactoring Intcode to be able to take in different input and output functions, which luckily I'd already done in the previous days. But then the second part of this puzzle was to take a sequence of numbers. I forget where it is. Somewhere they said 0 through 4, yeah. Each phase setting is used exactly once. So you've got 0, 1, 2, 3, 4. You need to find some combination of those that's going to give you the highest output. So the first part was working with Intcode and having it input and output differently. The second part is finding all permutations of a sequence of 0 through 4. So naturally I wrote my own, and then somebody told me later on, like, hey, Python has that built in, which was pretty funny. But in any case, that was the big challenge for part 1 for me, was writing that code myself. Intcode itself was not that big a deal. And then again, if you're playing along at home, they give you these input test cases. So they tell you, hey, if you've got a sequence of 4, 3, 2, 1, 0 and a program of this, you should be able to get an output of 4, 3, 2, 1, 0. And then they give you 2 more test cases, which is awesome. So let's check out my code and see what I had to do. So everything, I'm not going to type this out, by the way, because it's like 200 lines of really bad Python code. But essentially, this is the same as it's been since day 5, for part 1 at least. I haven't had to touch this. I just added to it. So I have some of the test cases copied over. I have my notes where I wrote, the first input is the phase setting, second's the signal, and then the first amplifier gets a signal of 0. Here's my code for permutations, so every possible combination of a sequence of numbers. Basically what I do is I recursively call this permutations function so that if it ever gets an array of length 1, it's going to wrap that array in an array and return it. And then down here, if it's bigger than 1, I'm going to slice a number off and then get the remaining numbers. And I'm going to pass those into the same function. And then when I get back out of that is going to be an array of arrays. And then so for each array in that array of arrays, I'm going to prepend the current number. And then I'm going to bunch all those combinations together and return that. So like basically for each number in the sequence, I then call this, which then calls itself. So it kind of will like flip the numbers and then put together a 2D array of combinations that it spits back out. So that was a lot of fun to write. That was what I spent most of my time on for part 1. But Python has like iter tools that will do that for you. It's a standard library, and it has, I forget what the method is, but it's in there. So I could have been done a little bit faster, but I think this was probably the beef of part 1. The second part was messing with the signals. So basically, I kind of cheated a little bit, and I have a function that is going to pass in as my output method. Basically, what it does is it just, whenever the program needs to output, it calls this function and it passes in whatever the output is, and it takes that output, which is the signal, and stores it to a higher level scope signal. So in this function, I've got the signal here, and basically every time an amplifier outputs, it's going to stick it in signal. And then whenever I run the next amplifier, I just pass that signal back in because my encode function was coded to take an input values array originally. So that bites me in part 2 a little bit, and we'll talk about that. But essentially, this lets me get the output for a sequence of numbers by running all 5 amplifiers with their phase settings in order. So basically, after that, I just grab all the permutations out of 0 through 4. I have my starting signal, which is 0, and I just loop over those sequences and grab outputs. And if I have an output that's bigger than the last output, that gets saved in the signal, and at the end I print the signal. So if we check that out, I get 20,413, which was the output. And again, I really relied heavily on these test cases to help me get there. So that was pretty critical. Part 2 is a whole nother ball game. So this was really difficult to wrap my head around. They changed things up. Now they're saying that you're going to create a loop. So instead of going from amp A straight through to amp E and being done, amp E is now going to call amp A, and it's just going to keep going until the amplifiers stop. The other thing that was kind of funky in here was where are we at? Basically, they say don't restart the amplifier controller software on any amplifier during this process. So what I took that to mean was the inputs that they give you. As the encode program runs, it writes to that array of numbers. So like when it's running something like this, amplifier 1 or amplifier A has a copy of this, and it changes values in here as it goes. And so what they're saying is whenever you're running an amplifier, don't pass it a new version of this or a new copy. Just let it keep reading and writing to and from it. The other thing that's kind of weird is how they didn't really explain how you're supposed to wait for A to talk to B and stuff like that. They just say let them all run basically, and whatever comes out of A goes into B. What I eventually found out that they intended by that was that like amp A is going to run until it either runs out of inputs or it gives an output. And then amp B is going to start, and it's going to run until it runs out of inputs or gives an output, and then so on and so forth. So basically, you have to be able to start and stop your int code program, which could be, depending on how you wrote it, a ton of refactoring. Luckily for me, actually unluckily because I spent a lot of time doing it, I was able to do it, but it definitely was a pretty difficult thing to pull off. So let's check out what I changed in there to get to that point. So I copied over all my stuff into part 2. I get inputs, which just parses the immediate and position mode thing. Hasn't changed. What did change was my int code program. So now whenever I hit a halt code in 99 first, I want to spit out done at the end of it. The other thing is, now for opcodes 3 and 4, whenever I have an input method, I'm going to get a value, and then I'm going to check to make sure that value is not false. And then if that means if I was able to get an input value, keep running. If not, I'm going to return the index that I'm currently at. And then that means that the next time this thing starts, I can just thankfully pass the index into it and let it keep going. So what ended up happening was that I was checking input value equal false instead of is not false. And basically what I was doing was I was reading the value 0. So I would get input value is equal to 0, and then 0 in Python is equal false. So basically I ended up in an infinite loop where I was never outputting anything. So all my amplifiers would just run one after the other, continuously waiting for input. So that was bad. It took me a long time to finally find this and go, oh my gosh, I basically did a double equals in Python instead of a triple equals. So that really tripped me up. What else? So aside from that, still had the permutations. I had to completely trash and rewrite my get output function. So now, because we have to keep track of the current index of each amplifier, like a buffer for each one, so its inputs basically, and its own array of numbers that it's running as a program, I basically created for each amplifier, basically each number in the sequence, its own dictionary to keep track of all that junk. And then I had to pass in the phase for each amplifier, as well as pass in the initial signal. So I'd check to see if I'm at amplifier A, basically. Then the next thing is I needed to figure out how to write a closure in Python, which was kind of tough, believe it or not. I ended up writing to and reading from the same buffer for a while. But what I ended up doing was I created this input method function, which returns its own internal input method function. Basically, it closes over this index. So whatever the index is at this point, I create a new variable for that and just store it for the life of this function. And then I check to see if I've got anything to output, and if I do, I go ahead and pop that off the top of the array. Otherwise, I say, hey, I've got nothing, or false. So what was happening here was I was popping 0 off of that array, and it was going, oh, 0 equal false. I guess you don't have any output, and it would just keep looping. I did the same thing with the output method, created a closure to grab the index. Here, I'm doing a fancy ternary statement, but what this is saying is if I'm at amplifier E, so basically if I'm at A, do a +1 to give me B's input for my output. If I'm at E, which would be 5, I think. Don't do that. Don't give me 6. Give me 0. So E is pointing to A's input. And then I had to, this is another thing that got me, instead of appending, because I'm popping off the array or the list, I have to prepend. So to do that in Python, you do an insert at index 0. So then after that, I just do a while loop that says, hey, just run forever, basically, until one of them spits out a done code. So I grab the output off of the dictionary. So I had a list of dictionaries for each amplifier. And what I did here was every time I run an amplifier, I have a counter. And I just take the mod 5 of that. So I would get counting up 0, 1, 2, 3, 4 over and over again. So then I run until I get done, or I get some kind of output. I think. Ambit next output. Okay, so I grab the amp dictionary that I'm working with. So basically, if I don't throw a done code, I'm going to return the current index that I'm at. Then I'm going to update that dictionary's index value so that the next time this thing runs, it knows where to start, which it plugs in right there. So if you look at my inputs or my parameters for int code, it's program, the input, the output, functions, and then the index at the end. I have to grab that index if I'm not done running the program. And then at the very, very end, because E's output is tied to A's input, or amplifier A's input, I just grab the first amplifier's buffer value, and that should be my output. And then the same thing as the previous one, go through all the permutations, loop through them, find the highest signal, and then print that. Which gives me 3,321,777, which was the value that I needed. So that's, I know that was a really convoluted, hard to wrap your head around solution to that. I'm sure people have done it in fewer lines of code, but especially with Python. But yeah, Python is not my forte, and I was happy with myself just to get this one done because of all the times that I tripped over a pass by reference instead of a pass by value, and like running over the same buffer or infinitely looping because I was checking a truthy falsy value or something like that. That really set me back on these. Although overall, I feel like I'm doing pretty good for Advent of Code. I hope I'm able to finish it. All right, so that's all for day 7. I'm gonna start recording day 8 now. All right, bye.